Many of you will be familiar with George Thomas's book Workshop Techniques, and there's a lot of detailed information on the pillar tool that he made in various forms with all sorts of additional add-ons, but it is a job not for the faint-hearted, especially if you go and produce the parts exactly the same as the drawings. The parts are available as a kit from Hemingway, and as I imagine, I don't know, but I haven't got a set of their drawings from them, and the parts that they sell would be a lot of machining, but no doubt well covered. The book's very good, so most of the dimensions and so on are included in here, enough to be able to make it if you chose to do via the book. So while I was checking out on that, I came across this article which David Haythornthwaite described making the pillar drill using cast iron pipe fittings, which struck me as being a rather clever way of doing something that would involve a lot less work than making it all from solid castings, and also a lot cheaper. So following his article, he machined everything conveniently on Myford, nice and simple, much easier to do than doing it on using the larger castings. And he described ways of assembling it and getting accurate results. How to do the cotter clamps. So I thought, well, I would follow what he more or less what he did. So I started, and I wasn't going to do much of an article on this, but in the end I got kind of hooked on it. I thought it might be useful to people. So what I've got, I started off. That's my column, and now this is bought off the internet. A faceplate, and I just bored out the centre to fit this, which is a 25mm column in 304 stainless. This is going to be the table. That is a 6-inch faceplate, and it's a small enough thread that I can bore that out to fit on without any problem. And I've just started so that I know I can, and I've checked that I'm going to be able to machine these parts with using the fittings that I got hold of, which are only just over £2 each, so they're not expensive, but they're very irregular in shape, and they do take quite a bit of getting a method and a way of holding them while you machine them, and they do wobble around like crazy. So I started off by giving them the castings a light sanding just to get the worst of the flash off, and then the next stage is to machine the ends and then the ring, so you can then hold it reasonably firmly in the lathe, so you can turn the inside of here, and I discovered that it is quite reasonably easy to do it and make it accurate, so that you can get the column through. So the way I've done it is exactly the same as David had used, with this piece of 35mm rod, which I will cut off, and each of these fittings will fit onto a section of this, and then I'll have similarly a section, there'll be a 25mm branch coming off here, and this will have a section of this inset in there and bored out to fit. So it'll become a bit clearer when I get a bit further on. So that is just really as far as I've got at the moment, but as I say, I've done enough now that I know I can make the parts. And at the moment I'm unsure whether to Loctite them on or to use metal epoxy. So I think probably I'll certainly use for this particular column, I use the Loctite for that, but the pieces in here, there might be some voids if I didn't fill it with glue, so I probably will use the metal epoxy for that, and I'll show you a little bit of the machining. The idea of this is to try and get something up and running reasonably quickly without, you know, making an absolute meal of it. It doesn't want to be 25 articles on the internet to do it. It should really be only just 2 or 3, because it is quite simple once you've machined these parts. They're the difficult bits, and this is mild steel, so that's easy to machine. It'll need a hole in it, and I'll obviously only cut them off here, so a short section of that fits in there, and that'll be nice and easy to machine. So there are quite a few to make, so I've got 6 to do altogether. And there's one more mounted on the lathe at the moment. So we'll go to the lathe and I'll just show you machining up the very wobbly casting. The most difficult bit to machine, I've discovered, is the inside of this one, which is at right angles, because you have to mount this into the four-jaw chuck, clamping there, and where I've cleaned this off, the casting off, so that it gets a proper seating with the jaw, which is only just that deep. So I've figured out I can do it, so I'm going to crack on now and make it up. Should be an interesting project. I'd like to have all of the top part made as per the book. I like it with the pulleys going down here and a motor at the bottom. So that's where I'm at now. It's an interesting, fairly simple project that doesn't need too much machining, and starting off with a bonus of 2 of the parts that require an awful lot of machining done for us. So and they're cheap to buy. So the whole thing is not going to be terribly expensive, and I will try and put a list of the parts, where I got them from and what the cost has come to. Okay, let's go to the workshop. Now I'm setting up now to try and get this casting reasonably closely aligned. The outside of this part is a long way from being round, and you are only going to get an approximate position for it. And when you're spinning this round on the lathe, you need to make sure that this part of the casting doesn't wobble around too much either. So I found the best way to do this is to not have it touching the whole way round, as you would normally do, but probably just to leave it so it only touches in one spot. So that's your high spot there, and then just to tap it. That's reasonably close. I'll just tighten that down a little bit. I'll see how wobbly that is. That's pretty good. That's certainly good enough now to be able to machine the face of this, which I need absolutely perpendicular so that I can turn it round and machine the other end, and I'll also machine this at the same time. So I think that's the first job to do. I'll get this out of the way now. It is very tricky to do this, and it's very easy to snag the tool, so you have to do minimum cuts and not too much swearing if it does grab it and pull it off. I put paper down to try and safeguard chunks going in of swarf from the cast iron going into the rest of the body of the lathe, and I don't want them going into my expensive chuck, so I put that in there as a plug to stop the bits going into the chuck. So let's give an attack on this and see if I can get this machined up. That's probably got an error of about 1 millimetre on that dimension. Only take the barest whisker off at a time. I think I'll leave it at that. I've got pretty well cleaned up. Try this surface now. This is much more difficult to do. Starting to clean up. You can see there's one part of the casting is a lot lower, and there's just a small section here that needs to come down to remove it. Okay, that's that done, and I can now swap this round and machine the other end. So if I take that out, you can see that there's a ring now, clean machined surface there. I'll take my little plug out, put a fresh one in. So hopefully that will go in and be reasonably true now. Yep, that's pretty true. And also it's gripping over a flat surface in here rather than the casting, which is very irregular in places. So that's much less of a strain to give those very tiny wee cuts to get at it. But this end no doubt will be probably about 1 millimetre off in terms of waving about and wobble, eccentricity. Yes, it's about 1 millimetre. Between the highest and the lowest point. That's the outer face of this end cleaned up really quite quickly. So I can now machine the cylindrical surface here. Just a touch more and that's that end done. Right, that's that end, and there's just a little bit of unclean part there. It's a little bit low, but that's only a minor bit, and the rest of it's completely cleaned off. So there we go. That's cylindrical with that end, and the plane of that is same plane as on this end, and I can now bore out the centre part. I'm now ready to bore the inside of this. I'm boring it just over halfway so that when I turn round and do the other end I can feel when I've got to the meeting point of it. And bear in mind these threads, pipe threads, are tapered, so you have to be a bit careful not to go taking too much off at the beginning. And I find on the DRO I can cut a cut depth of 0.25 of a millimetre is safe enough with it holding like this. make sure that's not moved in any way. $31.4. Okay, 31.4. $33.93, so it's pretty close. One cleaning up pass will probably, when I've finished, get me to the right dimension. And you can hear it cutting where the right angle is, where it's intermittent cutting at that point. All the threads have now been turned off.
35.8, so 34.8 before, so I'll just take a little bit more in very gentle cuts.
Just do one final check. .1. That should now fit the bit of. Right, I've mounted one of the connectors so that it's the other way round. These ends have been machined, so it's square about here, and these are also in line with each other. So if I can get these touching here, then I can adjust the spacing here to give me correct alignment in that direction. But the problem is, in this direction, these only just touch on the outside. So what I found was, if I take the tool out, turn the tool post round and back it up against here and keep pressure on that while I'm moving this in either direction, then it means that it almost certainly will come out reasonably true. But I found that this piece here is not anywhere near as accurately aligned as these were. So I'm just find that, start that up, the outside of here is certainly not true, it's just not round, and the face of this particular one was at an angle. I've trued it up already, but you can see the overhang's quite considerable, and only really being held firmly on that point. It is asking a lot of it to machine down the outside and across the face. But anyway, I'll leave this running and you can get an idea of what's involved.
With very light cuts. machined off to clean up.
Right, I'm now turned round ready to bore, and remembering that these threads are tapered inwards, I'd start near the back just to be sure that I'm not going to end up taking a lot off at the same time. see if we fit in. Yeah. Yep, that's perfect. When I've machined these, I've machined them slightly oversized in order to make sure when we put in the glue that the angle of this is set to 90 degrees exactly. Anyway, that's another one done. I've got one more to go. I'm set up to bore out one of the inserts that go inside the T-fitting, and this is one here that I've done, and I'm pleased to say I bored from one end, then turned it round and bored from the other end, and it now is a tight fit, well, sliding fit. Now I've machined this off, this plug, which is just a little bit, I think, too short, because where this sticks out, I'm going to use this as a reference point. Obviously that's dead vertical, and this needs to be 90 degrees coming out this side, so if these two surfaces are accurately machined, putting that in there will, and it sits on it, will be at 90 degrees, and then whatever's in here, bored the same as I've done this one, should be at 90 degrees as well. So I'm going to work on that basis, I think. So I'll machine a flat in here. There's space because this here, I can put a line up here. There's plenty of thickness in there to allow me to have a bit of a flat. So I'll machine a flat in there. I'll glue this in with Loctite. When I drilled the hole and bored the hole through here, you can't really see, there wasn't a step at all. That machined out absolutely dead clean. But I've got very nice jaws, a very nice chuck. It's extremely accurate, and it's nice joy to use for jobs like this. So I'm pleased that all fits together nicely, and this is the column, or the same material as the column, and it's not got any slop in it, and it's free to move up and down. So that I'm happy with. That worked out well. So I'm now going to do the others all the same as these, and then I'll have a set of 6, and I can then organise getting them glued in. And these are the pieces, and this is the flat on the top that I was talking about, and basically this locates on the top of there, and I need to make sure therefore when it's glued in here it's exactly vertical, and I've made this a very nice fit on here so it doesn't move around very much, but I have discovered that this, when it's fitted in here, does have a fair amount of movement, so I need to be very careful that when this is glued up that it sits vertical and doesn't move while the glue's setting. So the other thing I've got to think about is drilling through here to mount the cotter that goes through to hold it and lock it in place on the column, and that is drilled 17mm from the centre line of the bar, moved in here. So I need to figure a way of doing that. I can set it out on the mill quite easily, but and drill it if I can manage to mount it. So I'm going to think about that now. I'm doing this in a slightly different way than the various articles and books I've got, so I'll see how I get on. But at least I know I can get this vertical, or at right angle should I say, to the main column without a problem. I can measure it, and it's just a matter of when the glue sets to make sure it is still sitting in that same position. I've mounted the angle protractor, which is the simplest way of trying to get a 90-degree angle between the two bars. This is all assembled together now loosely, not with glue. So if I move this up here and I put it on here, you can see that that's exactly 90 degrees vertical, and I discovered that the best way to do that was to use the flat on the top of here to locate on a flat made in the filler inside here, and I can show you that in a second when I take it to pieces. But that seems to have worked okay, and I now need to figure out the best method of assembling all this. I think I'll probably glue the joining piece and the filler together first with Loctite, and I'll then decide what I'll do after that. When I assemble all this, I'll need to make sure then that this is assembled so that the filler piece where the flat is exactly at 90 degrees, with this sitting on top of it. So I'll take this apart and just show. Now I've made considerable progress in putting this, doing all the machining and putting test sample together. I left you previously where I had done this angle and glued it all together. The glue that I used, just to be clear, is JB Weld and Loctite 638, which I've found the best way to do it is to glue it in two different ways. So if I'll show this first. If I move this these can move freely. The joining sections here are exactly the same length, and they sit into a machined recess on the sleeve in here, and that's the same depth on each one of these. So theoretically, that if I clamp that, it should still move freely. But I think the best solution would be to glue solid this end, let the glue set, then put it together and glue the rest of this separately. And I'm going to glue it on the surface plate. This is my granite surface plate over here, and I'll cover it up now because I don't want to damage it. So if I take this apart, I can show you what we have here. These are glued together and each one of these is done like a dumbbell and they fit into here, where you can see I've machined in the flat step on the sleeve. This is glued together with Loctite 638. It's a little bit messy when you do it, because when you push this in, any surplus glue squeezes out along the edge here, but it seems to glue it fine, so I'm quite happy doing it that way. So what my next task will be is to epoxy in the sleeves, epoxy in the dumbbell end into there. So I got all three of these done. And then they need a lining on the surface plate, because these collars here are more or less equidistant from the centre of here. So if all this is fitted together and put on the surface plate, in theory that should all then be aligned perfectly, and so long as I can remove the rods afterwards, that's all that really matters. So if I put this all back together, so I shall be gluing this, I just say there's no danger of getting glue into here and getting these rods stuck in, because there's no clear path through from inside here. When you put the, I perhaps should explain this, when you put this part into here, this is completely sealed, and when you push this in under force, the air's got to have to go somewhere, and the surplus glue. So it is essential that there's some means of letting the air and the glue out. And what I did was, you can probably just pick out, there's 4 hacksaw slits at each quarter. And when I was doing the very first one, I only had one. First of all, I had no slits and I couldn't squeeze it up. So I put one slit in while it was glued, while I got the glue in, and that solved the problem, sort of, but I could see the glue was only oozing around this point, and it would have been better if I'd have had each quarter separately. So when I put this together now, I shall be able to get around that problem, so people can benefit from my experience of doing this, if anybody chooses to have a go at making this. So it just needs to, when it's finally put together, needs to be assembled reasonably firmly, but there's no need to clamp it, I don't think, unless I fail to get the glue excluded from it when I assemble it. So that's the next job to do, is to glue that up and then leave it to set. And I shall have to take it back to the workshop and do that in the workshop. So all told, I'm quite pleased with this now. The one problem I have got is drilling the hole. When drilling the hole through isn't a problem, and that's easy on the mill, because these 3 surfaces are locating the direction in which that goes, and I've centred off the either side of this bar with the mill. Then that gives me that dimension, and I've centred off here, and that gives me 17mm from the centre of here back. Is where to drill the hole, and that's reasonably easy to do. I drilled with a 5.5mm hole first, and then widened it out to 6mm. And the one problem I found was when I counter drilled at the other side of here, the hole went fine until I got to the point where it broke through and needs to break through into touch this. That is a problem, because the drill tends to wander off towards the hole in here. What I shall do next is I'll drill a little way down with the final size. I did them in 1mm steps up to 12.5mm. So instead of doing that, I did them like that. Each time I run a drill through, I'll take the drill out, and then I'll only do the drill down a modest distance. I won't go right the way down, and I'll clean up any drift that's happened with the end mill or slot drill, and just run it down. So I should be able to control that in the lathe, in the mill. I don't care for trying to drill this out, because this is quite hard steel. This is a bit of scrap EN24T which I had left over on that, and this is 304 stainless. I used stainless in here just so that there was no chance that the column could rust up, although of course the sleeves could inside there, I suppose. So the only slight problem I can see coming is that these bosses are quite big. Clearly this is going to be done away with, and if you just had the drill with this one moved up to the top and this one down at the bottom. There's plenty of space to be able to use it as a drill, but it might be a bit tight if this is on there with it. Not leaves quite so much room. So I need to think about that a bit later on. And this is the foot of this. I'm not sure whether I'm going to secure this with a grub screw or glue it. I think I'll probably put a grub screw in just so that I can take it off if I need to. Now, this has not taken me very long. Doing these was about a week's work, doing all the sleeves for inside here. Once I'd done one and I'd done the boring and everything, it was pretty straightforward. So I think that's as far as I can get at this stage. I've now glued one side of this with epoxy, and the other side has just got the Loctite in on the sleeves, and the rest of it I can disassemble. And what I've done is I've checked with the vernier caliper the dimensions across after having clamped everything together, and it's the same at this point as it is at this point and in the middle. These revolve quite easily, so I can get this apart, and you can just see here probably there's a black bit sticking out there. That's a little bit of the glue that's oozed out of the port there with I filed. So those have gone together very well, and I'm just happy with those. That's much more accurate than I could have done if I was machining solid castings, I'm sure. So I know when I come to do this side and disassemble these, I just assemble this part here with epoxy on it, and then the back part of this, the lower part inside the case, inside the casting, with epoxy in, squeeze it together, and then as soon as the face of the sleeve in here is tight up against the casting, I'll know that that's gone fully home. Then I can measure everything and just check it. I can clean it up as well, because the epoxy takes a little while to set. I can clean it up, as you can see here. The epoxy is very strong, and you really don't want to leave surplus of it lying around. It's difficult to get rid of. So far the gluing's gone very well, and that's going to be the worst part of this whole job, I think. This is the setup that I use for doing the drilling of the hole for the cotter pin. Rather nervously doing this, because it's quite a struggle to drill through the steel and everything all in one go. And the first hole, and you can just see here where the breakthrough is in the wall that secures it. So I drilled into the position here, and with successively larger drills going up to 12mm, and that's the largest size I can comfortably do without snagging the drill and stopping the mill. It's a bit of a struggle drilling this sort of size, to be honest, but never mind, it's drilled accurately in the place it's supposed to be. I drilled a hole right through 6mm, which is how the other one had been done, and there's a 12mm hole through now, which I can fit the cotter pin into. So I'll take it out and examine it and see if it all is well.